And then it'll be the weekend. So, here we go. We are in our notes on the back of page 53. And we're in 4.6 and we're looking at 1C. Now, I am not going to ask you guys to graph something funky like this by hand, but you certainly should be able to type this in on your calculator. So, I don't know what you've done with your calculator since last time, but check your window, because this problem says that we're between negative 2 pi and 2 pi, which means we are in radians, and that is x min and x max.
Are we doing 1A on
We already did 1A and B. We're doing 1C, which has the same directions, but now a different equation. So, it is those parentheses, kids, are really important. Be sure that you have those parentheses. Whoops. What'd you get? Did you get a series of bumps? Periodic? Yes. One bump is a period. So if you took that bump and just kept pasting it on, you would get your whole picture, right? So that was periodic. All right, what about D? Watch it. It looks a lot alike, but it's very different. Now be careful. Is it a reflection across the y-axis? Yes, which makes perfectly good sense, because when you square x, you're going to get the same thing, positive as negative. Is it periodic? No. No. Periodic means you would have exactly the same thing, that you would cut it out and paste it. And that's not what happened. You flipped it, but it is not periodic. Very, very good. All right, now I'd like you to graph number 2, problem 2. Did you get a sine curve, but on a slant? So the sine curve, the sine part of the equation, obviously what's given us the wave, and the 0.5x is a line, so that's kind of on that slant part. Now what the question is asking you is this. You have this thing going like this, and it's oscillating between these two parallel lines. Now you don't see the lines because they're not in there, but that's what's happening. And then your job is to come up with the equations of the lines. Now if you think about this for a second, you are going to know the answer. You don't have to do anything on your calculator. You don't have to mess around. It is super simple. Does anyone have a thought? Seth?
It's 0.5x plus 1 and 0.5x minus 1.
Exactly. So your two lines are y equals 0.5x plus 1 and y equals 0.5x minus 1. Now, Dylan, do you know why? Exactly. The highest sine value, so the top of those waves, the highest sine value is 1. So up 1 is where that's going to be. The lowest sine value is -1. So that's where the minimum is going to be. Beautiful, beautiful, beautiful. Isn't that easy? Yes. Totally love it when it all comes together. Okay. Number 3. By the way, if that had been a cosine, would that change anything?
No.
Nope. Because why?
So they would minimum and maximum.
Are the same.
So
Right. Now the picture might be a little different because cosine shifted from sine, but those parallel lines would be the same. What if we did this?
it would make it.
That'd be plus or minus 2. Easy? Yeah. All right, now what about this thing? Now we're not going to graph it. We're not going to graph it. You could, absolutely you could graph it. When you add 2 periodic functions, you get a periodic function. These two, this is going to repeat and this is going to repeat, and eventually when I put them together, it's going to repeat. Now, our job is going to be to find the period of the sum and to determine if it's sinusoidal or not. Okay. Okay. So, what is the period of this piece?
2 pi over 5.
What is the period of that piece right there?
2
2 pi. Because how do we find period of a sine or cosine? 2 pi divided by this coefficient, right? This coefficient has nothing to do with period. It's 2 pi over 1 or 2 pi. That's the period of that guy. Agreed? That's choking me up. All right. What's the period of this one? 2 pi. Now, when the periods match, then obviously the period of the sum is also going to be 2 pi. And we're going to see what happens when they don't match. But if they're the same, if the periods are the same, then that period is the period of the sum, and this is indeed considered to be sinusoidal. So something is sinusoidal when the periods of all of its pieces match. Now, I want you to graph it now on your calculator. And I want you to get a feel for what this looks like. Don't forget to close the parentheses after the x. Now, I had my calculator set for the last set of problems, so my window is -2 pi to +2 pi. So what I see on this paper, on this calculator, is 2 periods. Do you see the same shape twice? So the period of the thing is 2 pi. You're looking at 4 pi altogether, -2 to +2. There's 2 periods in that space, so one period must be 2 pi, exactly like you said. Now, sinusoidal, does that at all resemble a sine curve? Yes. Hills and valleys, right? Okay, so you've seen graphically what our algebra taught us. All right, let's look at B. Let's look at problem B. What is the period of the first piece?
2 pi over 5.
2 pi over 5. What is the period of the second piece? 2 pi over 3. This is not sinusoidal. In other words, when you graph this, don't do it yet, don't spoil the fun. When you graph this, it will not look like a sine curve, okay? However, it will be periodic. So whatever it looks like will repeat. Now I want you to think about this for a second. I am adding these two things together. This one repeats every 2 pi over 5. So assuming I'm starting at 0, it's going to start repeating at 2 pi over 5. Then it'll repeat again at 4 pi over 5, 6 pi over 5, 8 pi over 5, 10 pi over 5, and so on. Would you agree with that? That's how it repeats when you draw it. This one, on the other hand, 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on, right? The first place that they both start over again is the period of the sum. So notice that this one starts over again at 2 pi, and so does this one. So the period of their sum is 2 pi. Think about it for a second. You're adding these two things together. And this one repeats here, 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 and here. This one here, 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 and here. At this point right here, aren't they both starting over again? So that's creating the next section. All right, let's graph this one and see if what we thought happened does indeed happen. Now remember, if your calculator's still set like it was, you're looking at -2 to +2, right? Does it look like you have the same thing happening on the left side of your axis, that 2 pi units, as on the other side, that 2 pi units? So the period's 2 pi. Do you see what I mean when I say it's not sinusoidal? Yeah, it's got characteristics, it's got waves and stuff, but it definitely isn't sinusoidal. Okay, try the next one on your own. See what you can do with letter C. You're determining if it's sinusoidal and what its period is, because it definitely will be periodic. I think the period of this one's 2 pi also. Sinusoidal? No. The only way it will be sinusoidal is if the periods of each piece match. So as soon as you see they're not the same, you know it's not going to be sinusoid.
Is there a way you can do it without like listening to them?
Well, you got to figure out kind of what the least common multiple of those two numbers is. For me, it's easier just to list them, but if you can figure that out. Now, the last one, we are not going to be confused by all the letters and the fractions, because in terms of the question you've been asked, do the A and the C even matter? No. Notice that the coefficients on X are the same. So what does that mean about this thing? It's definitely a sinusoid, because the period of each piece is going to be 2 pi divided by 3/7. 14 pi over 3 is the period. Okay, nothing hard there, just a couple of things to remember. Is everybody good with that? 6 homework will be due Tuesday. Mark that in my trusty book. All right, now we're going to start 4-7. So here we go. 4-7 is about the inverse functions. Who can remember what we use the inverse functions for? To find an angle. I heard somebody say it. To find an angle. That's exactly right. The inverse functions find angles for us. So the first thing it says there is sketch sine x and its inverse. Now, sketching sine x, boys and girls, should be an absolute no-brainer for you. Sketching the regular sine and the regular cosine, those should be no-brainers. Now notice I did go back one period. There's a reason I did, or half a period. You'll see in a second. I want you to think back, way back. Does anybody remember the conversation we had a long time ago about being one-to-one? A function being one-to-one? Does anybody remember anything about that? Oh, you guys had a terrible teacher. One-to-one means you are a function and your inverse is a function. And when we test for me to be a function, the sine to be a function, we just do the vertical line test. Is that a function? Yes, we call it the sine function. Now, to test whether the inverse is a function, we use the horizontal line test. Is the inverse of the sine a function? No. And that is problematic, so we're going to talk about how we fix that. But first, let's graph the inverse. Remember, to graph an inverse, you simply switch the y's and the x's. Remember? So now my x-axis is going to be 1 and -1. This is going to be the inverse. This was the original. And my y-axis is going to have pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. Now, don't you dare be confused by that. You know this. To graph an inverse, you flip-flop the ordered pairs. So the x's become y's and the y's become x's. So, origin doesn't change. That's 0, 0, so that's going to stay right there. Pi over 2, 1 is going to become 1 pi over 2. Pi 0 becomes 0 pi. 3 pi over 2 -1 is -1 3 pi over 2. And then there. This one will be -1 negative pi over 2. And then so when I connect those dots, and I'll use a different color so it shows up a little better for you. When I connect those dots, does that make sense? That when I graph the inverse of this, I get this. And you can clearly see that the orange thing is not a function. Hank, you with us?
Yes.
Okay. Now, what it means to be a function is, there's one output for every input. So for example, on your calculator, when you say sine 30, it says 1/2. That would not happen with this orange curve. But your calculator must operate as a function, because when you type in something, it only gives you one answer. It doesn't give you like this or this or this. So to make this a function, and that's what we have to do, we have to artificially make this a function. We restrict ourselves to this part of the curve only. Because if we restrict ourselves to that part only, that's a function. The black piece is a function. And it covers the entire domain. It covers all the values from -1 to 1. I wouldn't want to consider this, the hill, or whatever you want to call it, that is not a function, right? So I consider this piece right here. When you are dealing with inverse sine, then all of your answers have to be between -π/2 and +π/2, or between -90 and 90. Okay, so let's try something. Let's inverse sine 1/5. Just on your calculator, inverse sine 1/5. Remember, π/2 is like a 1.57. So when you get decimals, is the decimal you got between -1.57 and +1.57? Yeah, let's pick another number. Let's inverse sine -2/3. Did you get a number in the right answer or right range down here? Inverse sine -2/3. Yeah. Any inverse sine you do on your calculator is going to come out here. Okay? So any inverse sine you do by hand, we're going to do some in a minute, will have to come out here. This is where they are. Now let's look at cosine. Cosine's going to have the same problem. So go ahead and switch the ordered pairs and see what shape you get this time. You're going to get this same basic shape, but of course it'll be shifted. So let's see if we can figure out how to shift it. Anybody have any questions about that? I just flip-flop my ordered pairs. Once again, that orange thing is not a function. But I want you to look at something. Before, when I did the sine, I picked the interval from, well, I did, some smart people way a long time ago, picked the interval from -π/2 to π/2. Would that interval work for the cosine? No. Is that a function? Is between my hands a function? No. So I need a different interval. The interval for the cosine, inverse cosine, is 0 to pi. So every time you inverse cosine on your calculator, the answer you get is going to be 0 to 180. You'll never get a negative. It's always going to be 0 to 180 when you inverse cosine on your calculator. It's the same thing with tangent.
That's great. So you actually
Okay, so I know you haven't done a lot of tangent graphing, but you need to remember that the tangent has asymptotes, pi over 2 and negative pi over 2, at all the halves, in other words. The tangent's undefined at the top and the bottom of the circle, so at 90 and 270. So that's where its asymptotes are, where it's undefined. And the tangent is increasing, so you remember this shape right here? And its period is pi. So I really have 3 periods graphed there. A little bit of overkill, more than I need. Okay. Now when I do a tangent, I don't really have any labels on the y-axis, right? I could put some on there, but there's no amplitude to the tangent, so basically I don't have anything there. So when I do the inverse, what am I doing now? When I do the inverse, I won't have any labels on my x-axis, but I'll have my labels on my y-axis. So clearly I've got a 0 at 0, that hasn't changed. And at pi, I have a 0. And at negative pi, I have a 0, okay. Now at pi over 2, this asymptote is x equals pi over 2. So when I flip the variables, now I'm going to have an asymptote at y equals pi over 2, and 3 pi over 2, and negative pi over 2, and negative 3 pi over 2. Now you can imagine I'm going to draw on a squiggly line, right? Do I draw on my squiggly line like this, do you think? Or like this, do you think?
I think I think it's the second way.
Here's how you can tell. These angles right here, these angles are between 0 and 90, right? What kind of tangent value do angles between 0 and 90 have? Positive or negative? Positive. It's got to be up here, guys. These are going to be negative. Another way for you to think about it is the tangent curve is increasing. increasing, its inverse will also be increasing. Now, its reciprocal will decrease, so don't get that mixed up. But its inverse will increase right along with it. Okay. Is this thing a function?
Yes. No.
Yes?
No.
This is not a function because it does not pass the vertical line test. So I'm going to do what I did before. I'm going to choose a section of it. Is that little chunk a function?
Yes.
And it exists between negative pi over 2 and pi over 2. So its what we call principal values are the same as the sine. The principal values are the same as the sine. So when I'm doing these problems by hand, if it is an inverse sine or an inverse tangent, I'm doing it by hand now, so I'll be drawing my little triangles. I'll draw them in quadrant 1 and quadrant 4, because that's negative 92, positive 90. So if you're doing a problem by hand, this is how you're going to draw your inverse sines and tangents. Your inverse cosine, on the other hand, will be drawn here or here, because its principal values are between 0 and 1/8, or 0 and pi. So cosine is what we call inverse cosine is what we call a top half function. Sine and tangent inverse are right half functions. Everybody okay with that? Okay, now the reciprocal functions go right along, some of them, with their normal function. So, let me make a little chart here.
But when you're running on code.
I don't think there's six.
Okay, so does it make sense that if sine, inverse sine, exists, try to remember what that looked like. Do you remember what that looked like that? So its reciprocal inverse thing is going to look like this. Is that a function? Is that a function? That would be the inverse secant, or inverse cosecant. So it also happens in quadrants 1 and 4. If the cosine happens in quadrants 1 and 2, then does it make sense that so will the secant? Now, what about the cotangent? Well, I don't know, we haven't done the cotangent. Oh wait, we did tangent though. Tangent's up here. What about the cotangent? Remember, it looks different than this. Let's examine that one. I think that's worth examining. Remember what the cotangent looks like? Has an asymptote, this is the regular cotangent. Has an asymptote here and an asymptote at pi. And it's decreasing. So what if I inverse that? I've only got one period there, but that's all I need. What if I inverse that? 2 would be a dot.
Oh, no, that's fine.
And I'd have an asymptote at y equals 0. And an asymptote at pi. This function decreases, so this one will decrease. Is that a function? That's the inverse cotangent. Is that a function?
That part.
Yeah, that part of it is. I haven't graphed the other parts. Those are the principal values. But notice, where do they run from? 0 to pi. So he actually belongs down here. So you have 3 of them that when you do them by hand, which is our very next thing, you have 3 of them that when you draw them, you will be in quadrants 1 and 4 only. Positive in 1, negative in 4. And then you'll have 3 of them that are positive in 1, negative in 2. All right, let's see what this looks like then in terms of problems. Here we go. First one says evaluate exactly in radians the angle whose sine is √3/2. When you see that notation, you are immediately thinking inverse sine, quadrant 1 or quadrant 4. That's what you're immediately thinking. Since that is a positive number, would you agree I will draw it in quadrant 1? Any of them, any of the 6, inverse sine, cosine, tangent, all of them, if they're positive, they're in 1. 3 of them, if they're negative, they're in 4. 3 of them, if they're negative, they're in 2. This is a positive number. The sine is √3/2. Do you recognize that angle? How big is it? That's a 60. So in radians, it'll be pi/3. 60 is a third of 180, so pi/3. The angle whose sine is -1/√2. Now, it's another sine, but this time its value is negative. So it won't be in quadrant 1, it will be in quadrant 4. And we have -1 and √2. How big is that angle? 45 or pi/4? Now remember, the answer to the question has to be between -pi/2 and pi/2. It has to be. So how are you going to answer that question? -pi/4. That is exactly right. Is that you, Anna? You're exactly right. Now there will be times, other problems, they don't work like this, where you will use this answer. But not if it's an inverse sine. If it is an inverse sine problem, then you are restricted to 1 and 4 between these values. Uh-oh. This is a 0. Can I draw a triangle with a side of 0?
No.
No. So therefore, I must look at the circle. The unit circle. And since it's a tangent, I am only allowed to look at this part of the circle, because it's -pi/2 to +pi/2, right? Now, somewhere, either here, here, or here, the tangent is going to be 0. Which of those angles has a tangent of 0? Oh, my head's ready to explode. Tangent is y over x. Where is y over x 0? No!
0.
0 over 1. 0 over 1 is 0, right? 1 over 0 is not. So the answer to this is 0 degrees.
Thank you.
You guys need to brush up on your basics here a little bit. All right, where is the cosine 0? Now again, you can think about cosine as adjacent over hypotenuse, but the adjacent can't be 0. So we're not going to think about it as a triangle. We're going to think about our circle. But this time, when we think about our circle, we are thinking about the top half of the circle. Because the inverse cosine is between 0 and pi. That's this, right? So thinking about these points, where is the value of the cosine? X over r, or the x coordinate in the unit circle, where is that 0? 90 degrees. So in radians, we would say pi over 2. But it is, it happens right there. That's where the cosine is 0. Will you try this one by yourself? You better be able to do it. The angle whose cosine is 1/2. The angle whose cosine is 1/2. You can draw a triangle for this one. So much to think about. The first thing you're thinking about is, where do I draw it? Quadrant 1. Now, it's an inverse cosine, but remember, inverse anything is in quadrant 1 if it's positive. So it wouldn't matter what this was. I would draw it in quadrant 1. How big's that angle? This is, watch it. Pi over 3 would be over here. So isn't that a 60? Or pi over 3. You label your angle based on what side is across from it. All right, try the next one. This one's a little tougher. The angle whose tangent is negative root 3.
We don't have inverse.
You should. Thank you for pointing that out. That's my mistake. Yeah, it's an inverse. Try to get up to fix that. So, question number 1. As you're thinking the problem through, I've got to draw this triangle. Where am I going to draw it? What are your choices for inverse tangent? 1 and 4. It can't be 1 because it's a negative number, so it must be in quadrant 4. So here's my triangle in quadrant 4. The tangent is negative root 3 over 1. Think of that as a fraction. How big's this angle again? It's a 60-degree angle, but it's pi over 3. But since I gotta go this way, it will be negative pi over 3. just the way it is. Somebody really smart a long time ago said, that's how it's gonna be. And that's the way your calculator is built, that's the way computers are built, so that's what we're gonna do. So the tangent is -1. That happens again in quadrant 4, doesn't it? What's that angle? 45, which in radians is pi over 4, but it'll be negative because we're in quadrant 4. Every positive gets drawn in 1. But the negatives, you have to pay attention to what function you have. Okay, one more. Oh, this is a good one. This is a good one. Where am I going to draw the angle whose cosine is -√3 over 2? Where am I going to draw that? Second quadrant. Because inverse cosine is quadrants 1 and 2. So I'm over here in the second quadrant. And my cosine is -√3 over 2. So, how big is that angle right there? 30, which is pi over 6. A third of 180, a sixth of 180 is 30. What's the answer to the question now? 5 pi over 6. Perfect. Your angle must start being measured right here. This is the answer to the question, which is 5 pi over 6. One more time to make sure we're all summarized here. There are 3 functions that, if they're negative, are in quadrant 4. Those 3 functions are inverse sine, cosecant, and tangent. The other 3 are negative in quadrant 2. Okay, let's look at this next problem, because this looks a little bit exciting. Can anybody read this problem to me? What am I doing in this problem?
Cosine of the sine.
I am finding the cosine of the angle whose sine is 1/3. This literally says, find the cosine of the angle whose sine is 1/3. So in other words, there's an angle out there somewhere whose sine is 1/3. Wait, where would I draw a picture of that? First quadrant, it's positive. And the sine is 1/3. Now, boys and girls, this is not a 30, 60, 90 or something. But that's okay. Because I don't care what the angle is. I just need to know its cosine. So won't I know the cosine if I just find this side right here? And do adjacent over hypotenuse? Okay, so what would this side be? And I swear, if you say √10, I will come back and smack you. It is not √10. What is it? √8 or 2√2. Remember, when you do the Pythagorean Theorem, it's side squared plus side squared equals hypotenuse squared. Joseph, are you feeling okay? Okay, this is some of the coolest stuff we've ever done. So let's enjoy it, okay? Now, what's the answer to the question then? 2√2 over 3. Now, here's what I want you to do. Would you, on your calculator, would you take the square root of 8 and divide it by 3? Is that what you got? Okay. Now, I want you to type this in on your calculator and see that that's exactly what you get. So type cosine, second sine, 1 divided by 3. You do not need to add any parentheses, the calculator does it for you. Cosine, second sine, 1/3, and did you get 0.9428? Yes. So that's how you would do it on the calculator. We did it by hand. All right, we're gonna finish this last problem, guys. Hang on, you've been really good so far. Let's get this last one done. We're finding the tangent of the angle whose cosine is -2/5. And we're doing it without a calculator. What?
Quadrant 2.
Quadrant 2. I'm gonna draw my angle. Remember, this is the angle. This is what you draw a picture of. And he said it's in quadrant 2, and he's exactly right, because that's where inverse cosines are negative, right? So we put -2 and 5. Then we'll do our handy dandy Pythagorean Theorem. Again, side squared plus side squared is hypotenuse squared. So this is going to be 25 minus 4, root 21. So I drew a picture of my angle. That's my angle. Now what do I want to know? Tangent. So tangent would be root 21 over -2. All right, well, you guys were a little iffy there for a while, but things worked out. We got it.